Hello and welcome to this supplementary video lectures on Structure Analysis 1. For this additional learning resource, I am your instructor, Professor Hussain Rangwala. Welcome you. Today's topic is Analysis of Plane Truss, in which we are specifically going to discuss about method of joint and practice example of it. This session is designed to provide the extra support and clarification of the key concept, and also it will be help you to better understand the subject matter. With this session, we will work through the examples in which we will discuss some key points and provide the additional explanation, which will be reinforce your learning for the analysis of trust. Let's get started with our first topic, that is a assumption in the theory of the trust. As we have discussed in the previous session in the class, there are few assumptions before analysis of the trust we have to discuss. I'm just going to briefly discuss about this assumption. First one, that as you can see in the figure, all these members are straight and connected at the end by the hinge connections. The load which is acting at the joints only, self weight of the members are neglected, and cross section of the member is generally it's a uniform. Last, the member of the truss carry on axial force, either be in a tension or in a compression. So it can be like this. So generally, these are the assumptions which we are going to use in the analysis of truss. Now, analysis of the truss are using two methods. One that is called as a method of joint. Second, that is a method of section. For today's session, we are specifically focused on the method of joint. So before going to the practice example, first let me briefly discuss about the steps, and that same steps we are going to follow in the form of the practice example. Step number one, first we have to determine whether the truss is a perfect or not using the equilibrium condition. Or basically this is nothing but we are checking the stability of the truss, and we are defining either this truss is a structure is a determinate or indeterminate. Then second step, that is a most common for the both the methods, that is a determine the support reaction using the equilibrium conditions. Third step, consider any joint which has the only two unknown from the visual observation. Always we have to go for the one by one joint. First we have to choose the joint which having the maximum two unknowns. Okay. Then we have to draw the free body diagram of that joint, and we have to assume the direction of the unknown forces in the free body diagram. Find the angle of that each member, or basically it's a nothing but it's a geometry of the truss, and with respect to horizontal or vertical axis. Once we are ready with the free body diagram, we have to apply the equilibrium condition at the joint, and we have to find out the unknown forces. So that one joint unknown forces are over, then that same procedure we have to repeat for the remaining all the members. So this is a typical procedure which we have used in the class earlier, and now still with one more practice example we are going to solve. So this is an example in which the geometry is like this. It's shown in a figure. There are total seven joints are there. Sorry, it's a seven joints are there, and at the specifically 3 point joint G, F, and E, there are 3 point load are acting 300 Newton, 250 Newton, and 150 Newton. The one of the angle is given 30 degree. Remaining angle as and when required we will going to determine. As of now, I have considered this as a sign convention that upward forces and right hand side forces in the each free body diagram I will consider as a positive. The opposite sign to it we will consider as a negative. So let me start with a solution of this practice example. We are going to start from the joint E. So as you can see from the joint E, here I will highlight this joint. What we can see that there are total three forces are acting. Right. One is a joint force is a 150 Newton in a downward direction. Member force that is a FDE and member force that is a FEF. So let me draw the free body diagram. 150 Newton. I am assuming right now as a FD is a compression member, FEF as a also compression member, and angle of that force is a 30 degree. Now this free body diagram is ready for the joint E. We have to apply the equilibrium condition to identify the member forces. I will remind you here that we can assume the any direction. As of now, I have assumed both the forces as a compression. It's not necessary. It's up to you, right? You can assume anything. At the head, if your answer is a minus, we have to change our sign. The indication of the answer is a minus, that our assumption, whatever we have assumed in the free body diagram, that is not correct, and we have to change that direction. So as of now, I have assumed both the unknown forces are compression. Let me start with our first equilibrium condition at the joint E, and I will apply summation of the vertical forces equal to 0. So how many vertical forces we can see over here? That's a 2. One is a FEF, right? That is a going upward side when we are taking the component of this inclined force, and there is a another is a minus 150. So that's a FEF sine 30 minus 150 equal to 0. And if you are going to find out, so it's a 150 divided by sine 30, so answer will be going to 300 Newton. Next one, we are got the answer is a plus. That means whatever assumed direction we have considered for the FEF, that is a correct. Next joint, for the joint E, we are applying the second equilibrium condition, that is a sigma equal to 0. So there are two horizontal forces we can see in the free body diagram. One is a FDE and second is a FEF cos 30. Both are acting in the right hand side direction. So this is our equation. We already got the FEF from the previous one. So we are putting that 300 Newton in the this condition. So we will get the FDE equal to minus 260 Newton. So let me summarize this joint. So what is our final force in the FDE? That is a 260 Newton tension, as we have assumed the compression. But as the sign is a minus, that means we have to change our assumption, and actual force is a 260 Newton tension. And similarly, second one is a FEF, 300 Newton compression. So this is a joint E member forces. Now we are going to move to the next joint, that is a joint D. So let me go for the joint D, and we will try to draw the free body diagram of the joint D. So how many forces we can see? One is a FDE, second, and FDE force already we have find out in the previous joint, which is a 260 Newton tension. Second force we can see, that is a FCD. Okay, I am assuming right now is a tension. And third force I can see over here at the joint, there is a FDF, which is a, again I am assuming is a tension. So if we are applying the equilibrium condition over here, so what we can see here, that if we are applying the sigma v equal to 0, there is only one vertical force we can see, and that's why FDF equal to 0. And also based on the geometry, as we have discussed in the class also, this is a nothing but it's a T joint over here. So in such case, the force member force would be 0, and this is also called as a zero force member. Similarly, if we apply the sigma h equal to 0, we can see the two forces FDE minus FCD equal to 0. So FCD is anything but it's a 260 Newton. So the summary of this joint is a FCD is a 260 Newton tension, while FDF equal to 0. So that's about the joint D. Now we can go to the next joint. We can't move to the joint C. If you see over here, there are four forces are there: FBC, FCD, FCG, and FCF. Out of that, three are unknown. So as we have discussed in the initial in the steps also, what is the rule of the math? I will remind you that we have to choose a joint which having the maximum two unknown force. So definitely we have to go to the next joint, and that is a joint F. So let's move to the joint F. So you have to imagine the free body diagram first. And first what we are going to do that we have to write the whatever known forces are there. So let me draw the free body diagram. So here there is a FDF is a zero. So this is a kind of the optional, as it is a zero force member. If you are not showing the force, then also it's okay. Or you can show the force and you can write the zero. Anyway, it will be not considered in the calculation. Next one, you can see there is a 250 Newton force acting downward at the joint F. Another one, there is a F. EF you can consider, which we have got in the first joint, that was a 300 Newton compression. Remaining two unknown forces we can assume as per the any direction we can assume it. So first we have to decide the angle. So here, as you can see here, that's the angle is a the angle over here. That's a 30-degree, right? So this angle will be also going to 30-degree, right? So here I am, let's move to the here, that's a 30-degree. Next one, we have to find out the angle of the FGF and FCF. So as you can see that this horizontal line is making the angle with these inclined members, so that is a 30-degree. So for FGF also, the force will be acting at the 30-degree with the horizontal axis, which will be same. So I am assuming right now as a tension. Now question is about the FCF. What is the angle? So here let me show the tension force. I am assuming we have to figure out the angle. So there are multiple ways. First way I can show you here, that as here both, if you consider this triangle, right? I am highlighting the triangle like this, C, F, and E. So here both are 4 meter. This is a central leg. So if this is a 30-degree, so this one will be also the 30-degree, right? So this is a one way. So that will be also acting at the 30-degree. I will we will see with one more another way for the calculation. So I will consider this much of the theta, that what is the angle of the CFD. For that, first I have to consider the triangle, which is the nothing but EDF, which is highlighted over here. So in that, the angle is given, 4 meter length is given. We have to find out the length DF. How to find out that length DF? So we have to apply the trigonometry principle, tan 30, that is equal to DF by DE. So we will get the DF, that is equal to 2.31 meter. Now we will go on the another triangle. Now we know that DF is a 2.31 meter. So what is the theta equal to for this triangle? That is a CDF. What is the theta will be? That is a, yes, it's a tan theta will be CD by DF. Okay. So theta will be become nothing but 60-degree. So if you see the geometry, if this is a 60-degree, so remaining this is a 30-degree. So there are multiple way you can see the geometry from the any of the conditions. So we got all the inclined forces. We have shown the angles in the free body diagram. Next, we have to write the equilibrium conditions. First, we are going for the sigma v equal to 0. So how many vertical forces are there? There are one is upward, right? Remaining all three are going downward. If you take a component of the inclined forces. So F sine 30 minus FEF sine 30 minus FGF sine 30 minus 250 equal to 0. So FCF is unknown, FGF is unknown. So that will be become a linear equation. So if we are simplify this equation, it will be like this. FCF minus FGF equal to 800. Next, we have to apply the second equilibrium condition, that is a sigma h equal to 0. How many horizontal forces we can see? There are three components. All three are going on the left hand side. So all we will consider as a minus. Minus FCF cos 30, minus FGF cos 30, minus FEF cos 30. So again, we will simplify the equation. So it will be like this: minus FCF minus FGF equal to 300. If you add these two equations, so FCF will be cancelled out. The answer of the FGF will be become a minus 550. You have to just add these two equations, right? It's a two simple linear equation and solution of it. If we are applying the FGF of the minus 550 in this, so we'll get the FCF, that is a 250 Newton. So what is the basically summary of this one? That here we have assumed the FCF is a tension as the answer is a plus. So the force is a tension. While FGF that we have assumed as a tension, but it's a sign minus, which is indicating that that force is a compression. So this is a summary of the joint. Next, we are moving to the joint G. Can we move to joint G? No. Why? Because there is a still three unknowns: AG, BG, and CG, right? So we have to, there is only one way that we have to go to the joint C. So let's focus on the joint C. How many forces we can see? There are four forces. Out of that, two are known and two are unknown. So first one, FCD, which we have find out in the previous joint D, that is a 216 Newton tension. Then FBC, there is another force we are assuming again as a tension. There is a one more force FCG, I'm assuming as a tension. And last one, there is a FCF, that was a tension which we have find out of previously, that is a 250 Newton. And the angle was 30 degree. We are going to apply the condition equilibrium equation, sigma V equal to 0. How many vertical forces are there? That's a FCG and FCF sine 30. So FCG will be become a minus 125. So one thing you have to remember, don't change the sign or write the nature in between the joint, because we are considering the answer based on this previous diagram. So in between you don't have to change the sign. Once the joint is over, then we have to write the summary, and that we have to implement in the next joint. So we are going to do the summation of the horizontal forces now, and that's F minus FBC plus FCD plus FCF cos 30. And we are applying this FCG over here. So finally, answer will be nothing but it's a FBC equal to 476.51. Summary of this joint, FBC will be nothing but it's a, we have assumed as a tension. Answer is a plus. So FBC is a 476.51 Newton tension. And FCG is a minus, which is indicating we have assumed as a tension, but it's not tension, it's a compression. Last but not least is a joint G. So it's again little bit tough, as like a joint F, we have to do little bit more work on the geometry because we don't know the angle of this inclined forces. So first, I will mention the known forces: 300 Newton downward, FGF, which we have found earlier, 550 Newton compression, that was acting at the 30 degree. Similarly, FAG, I am assuming as a tension, and that is also acting at the 30 degree. FCG, that was a compression, 125 Newton downward, and we have to assume the FBG, that also I am assuming as a tension. But we have to find out the angle of the FBG. So can you think about it? So let me see it. Here we have to similar manner as we have done in the previously. Here we have to consider this as a theta. I will consider this triangle, highlighted triangle, you can see ECG. In that, horizontal length is a 8 meter. This angle is a 30 degree. I have to apply the 10 30. So it will be CG divided by CE. CE is a 8 meter. So it is a CG is a nothing but it's a 8 multiplied by 10 30. So it will be 4.62 meter. This vertical distance is a 4.62 meter. Now, if I will find out this theta, so This is a triangle I will consider. There is a BCG. There is a highlighted over here. So in that, if we are applying the tan theta, so that is a BC divided by BG. Okay. So we have find out this CG. So what is a remaining is that is a we have to find out the theta. So that will be 40.88 degree. Now, if we have to find out this horizontal angle, which is making this force with horizontal axis, so we have to do the 90 minus theta, right? So the angle will be nothing but it's a 49.11. 90 minus 40.88. So it is a 49.11. So it is not necessary that these two members are parallel. So both will be the having the different angles as we have calculated. Now last we have to apply the condition equilibrium equations in this joint. Sigma v equal to 0. So you can see the number of forces over here. FBG sine 49.11, that is a positive, it's going upward. Remaining all forces are downward, there is a FAG sine 300, 125, and FGF, there is a 500 sine 30. 550 sine 30. So if we are again, if we are going for it, there are two inclined forces are unknown. We have to make a equation, and if we are simplifying this equation, it's something like this: 1.5 FPG minus FH equal to 1400. Last sigma h equal to 0. Similarly, there are three horizontal forces. There are all three are going left hand side. We consider all three as minus, and if we are simplifying this equation, we'll get the something like this: minus 0.75 FBG minus FAG equal to 550. Again, we have to deduct the equation number 1 minus 2. So we'll get the answer as FBG equal to 377.78 and FAG equal to minus 833. So what's the summary of this joint? This is the last joint. So if we summarize, it's a FBG is a tension while FAG is a compression. At the end, what we have to do, we have to summarize whatever member forces we have find out in each joint. We have to make a summary. So let's make a quick summary over here in the member BC that we have find out at the end 476.51 nature was tension. Member CD 260 tension. Member DE 260 tension. Member EF, there is a 300 compression. Member GF 550 compression. AG, there is a 833.33 compression. Member BG, which is an incline member 377.78 tension. Member CG, there is a 125 Newton compression. CF 250 tension, and DF was a zero force member. So you can see in the figure as well that whatever blue color forces are shown, that is nothing but so force members are in attention, while the purple color forces are shown, that is nothing but compression members. So whenever we have to design, so we have to design according to the nature of the force. Last, we are concluding this session with the help of the review questions. So there are few review questions are there. You have to think about it. You may comment. You may, if you have any difficulty, you can ask me personally to anytime. So first one, identify the stability condition of the truss. We have not discussed about the stability of a condition because the aim of the today's session is just about the analysis of the truss using method of joint. And right now, as we are learning about the determinate structures, so we have not discussed about it, but you have to think about it as the it is a little bit different as we have calculated earlier. So you may think about it and calculate and think about the answer and comment it on this video. Second one, for any truss, how to decide from which joint we have to start in this method. We have already discussed in the session, although you may think about some real life geometry of the truss, and you may think that from where we can start the analysis. Third one, based on the observation, can you identify which members are zero force member? So, as I have told you, one of the logic, similarly, we have discussed in the class also that whenever there are some of the member based on the observation directly, you can identify that which is the zero force member. What is the advantage of it? That you can reduce your sum of the computation. And last question, what is the significance of the zero force member? So that is again the interesting question. So all are the review questions based on the today's session that you have to think about it and you may comment on this video. So that's all for the today's supplementary session on the topic method of joint for analysis of plane truss. This concept are really understand. It's interesting to understand, and I hope this session is a help clarify your doubt you may have or had. So, if you had like to explore this topic further, I recommended some of the resources already in the mail earlier. And in our next lecture, we are going to discuss about the practice example or method of section. If you have any question or need further clarification on this topic, please don't hesitate to reach out to me. Thank you for joining today.